Hi everyone, it's Miss Costa here, and in this video we're going to go through some of the questions that could come up on paper 2 that's occurring on the 3rd of June. Okay, so for the first question I've got a sharing into ratio. So I'm told Azim, Zaid and Emil shared some sweets in the ratio 2 to 7 to 9. Now Emil got 20 more sweets than Azim did, and I need to work out the total number of sweets that they shared. So if ratio is not your strong point, what I would strongly recommend is you to just draw out what parts there are. So Azim gets 2 parts, Zaid gets 1, 2, 3, 4, 5, 6, 7, and Emil gets 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So what this question is requiring you to do is to think about the difference between Azim and Emil's parts. So Azim has 2 parts and Emil has 9 parts. So Emil has 7 more parts than Azim does. So that must mean that 7 parts in this ratio is equal to 28 sweets. So if you draw it out and physically see, you can be like, okay, well, Azim has 2, Emil has 9. So if I subtract 2 from 9, I know that Emil has 7 parts more. So if 7 parts is equal to 28 sweets, you could figure out what 1 part is equal to. So we divide by 7 to get 1, and 28 divided by 7 is 4. So I know that 1 part is equal to 4 sweets. So each of these parts are equal to 4 sweets. So then I just need to figure out how many parts there are in total in the ratio. So I would do 2 plus 7 plus 9, which is 18. So I know I've got 18 parts, and if 1 part is equal to 4 sweets, I'm going to do 4 times 18 to figure out how many total sweets there would be. And this is a calculator paper. I don't have my calculator on me. What I would do is 4 times 18 is the same as saying 2 times 36, which is 72 sweets. Okay, so the trick here is realizing that it's a more than question, so you have to compare the ratios and the parts. Okay, in this question, I'm dealing with writing a number as a product of its primes. So when they ask this question, they want you to actually write the number as in 120 equals. Product is a multiplication. Prime factors are the numbers 2, 3, 5, 7, 11, so forth. And factors are numbers that multiply into your number. Now, the best way to do product of your prime factors is just with a factor tree. So we start with 120, and then we're finding 2 factors, 2 numbers that multiply to make 120. It's always easiest if you just do divide by 2 first, the first prime number. So we've got 2 times by 60. Now 2 is a prime number, so I'm going to circle it. Then we're going to try again. So what makes 60? 2 times by 30. Once again, 2 is a prime number, so I'm going to circle it. And then 2 numbers that multiply to make 30. Again, I'm going to do 2 times by 15. And now here with 15, 2 is not a factor of 15, so I'm going to try the next prime number, which is 3. And 3 times by 5 gives me 15. So I'm going to circle those. You only circle the prime numbers because the tree then gets extinguished. If you actually worked out the factors, you'd always end up getting itself and 1, so it would just be going on forever. So the key is to write it as 120 equals, and then a product is a multiplication. So it would be 2 times 2 times 2 times 3 times 5. And you can simplify that to 2 cubed times by 3 times by 5. But it's really important to actually write it. So you're being asked to write 120 as a product of its prime factors. So if you just left the factor tree, that's just your working. That's not the final answer. So make sure you actually just write that. For the next question, we are told to write down the lowest common multiple of A and B. Now, the lowest common multiple, when we're doing Venn diagrams, is when we put everything into the Venn diagram, and the lowest common multiple is when I multiply everything in that Venn diagram. So they've already kind of given A and B to me as products of its prime factors. So that will make it very easy for me to put into a Venn diagram. So A is 2 times 2 times 2 times 5. B is 2 times 5 times 5. So what do I put in the middle? Anything that is common. So I've got 1, 2 that is common to them. and I've got 1 5 that is common to them. Then the rest, A, well, I'll put 2 and 2 here and 5 over there, and the lowest common multiple is going to be when I multiply everything inside the Venn diagram. So 2 times 2 times 2 times 5 times 5 is going to give me 400. Another way you could have done this is you could have actually just worked out that A is 8 times 5, which is 40, and B is 2 times 25, which is 50, and then listed the multiples and done it that way. Oh, actually, it should be 200. 8 times 25. Yep, so good that you spot a mistake, and I could have easily used a calculator to correct that. So make sure you use your calculators. They're just right in front of you, especially for a calculator exam. So yes, those are the 2 ways that we can do those questions. Okay, so here I've got an exchange rates question, and what's really important when I've got questions like this is to create a comparable. So either you want to work out the price of, let's say, 1 gram, or you want to figure out the price of how much £1 would get you. Now, I think that what I'm going to go for in this question is grams. So let's see what's going on. So in London, a portion of churros weighing 180 grams costs £3.60. In Barcelona, a portion of churros weighing 300 grams costs €4.50. So let's just start by figuring out what the costs are in London. So in London, 180 grams costs £3.60. So what would be a really good comparison was maybe if I figured out what 100 grams cost, because then if I know what 100 grams cost in London and Barcelona, I can directly compare them. So how do I get from 180 to 100? I'm going to have to divide by 1.8, and it's a calculator paper, so your calculator can do all the hard work for you. So I'm going to divide by 1.8. So £3.60 divided by 1.8 is 2. So that must mean that in London, 100 grams costs £2. So now I want to do the same for Barcelona. So in Barcelona, I know that 300 grams costs €4.50. So what could I do to figure out how much 100 grams is? Well, I'm going to have to divide by 3. So I'm going to divide by 3 here as well, which is €1.50. So now I know how much 100 grams costs in each city, but because it's an exchange rates question, what I need to do is convert one of the currencies into the other. So I'm told that £1 is €1.15. So I know that in London, 100 grams is £2. So this one would be quite easy to convert to £2. So £2 is going to be €2.30. Okay, so I've worked out what £2 is in euros, and now I have 2 comparables. So it says, in which city are the churros better value for money? Well, 100 grams in London is €2.30, whereas it's €1.50 in Barcelona. So therefore, Barcelona is cheaper or better value for money. Okay, so that's the key thing with exchange rates questions. Try and separate it, work out a unit cost, and then you can compare them easily. Okay, so here we've got a compound interest question. So the key, or like the formula that we use for compound interest is whatever your original value is, times by the multiplier to the power of n, which is the number of years. So that's what we want to think about when we're doing questions like this. So I'm told that the Bank of Barcelona has 2 types of bank account, and both accounts pay compound interest, which means that all the money that you put in, you're going to get interest on everything that you've put in, and each year it's going to increase and increase. So Misha invests £1,800 into the cash account, and Shiv invests 1,500 into the stocks and shares account. Work out who will get the most interest by the end of 4 years. Now, this is a key part of the question because so many people get caught out by this. It says work out who will get the most interest by the end of the 4 years. So just be careful you don't get caught out by that. So let's use our formula. So for Misha, we're going to do 1,800 times by the multiplier. Now, if you're not sure how to do multipliers, what we do is we say that the original amount is 100% because that's what you started with. And then we're going to add 2.8%. So that would give you 102.8%. And what does percent mean? It means divided by 100. So either you can do that in your calculator or you're familiar with multipliers, so you know that the multiplier would be 1.028. Some people forget that you're working out, some people just use 0.28 because they're trying to work out 2.8%, and that's fine because here in this case actually we're only dealing with interest. But that would only work for 1 year. So just stick to the formula and work out your multiplier by starting with 100. So it's going to be to the power of 4. So what would Misha's amount be? We type in 1,800 times by 1.028 to the power of 4, which is £2,010 and 23 pence. It's always better to like round up with money. So Shiv, we do 1,500 times by 1.032 to the power of 4. Again, because I would have done 100% plus 3.2% and then divided by 100. So 1,500 times by 1.032 to the power of 4 is £1,701.41. So how much interest did they get? So for Misha, we do 2,010.23, take away her original amount. So the interest that Misha earned was £210.23, and the interest that Shiv earned would be 1,701.41, take away 1,500, which is £201.41. So who earned the most amount of interest? It was, in this case, Misha. So what a lot of people did is they just worked out these amounts, but they didn't think about the interest part of the question. Now, in the third year, the interest rate for the stocks and shares ISAs increased to 4.5% per annum. Per annum just means annually or per year. Does this affect who would get the most interest? So what I need to do is rework out what Shiv's interest would be. So for the first 2 years, it was the normal interest of 1.032. So I'm going to do 1.032 to the power of 2. But then for the next 2 years, it increased to 4.5%, which would be 1.045 as a multiplier. So I would do that, input it into my formula. So 1,500 times by 1.032 to the power of 2 times by 1.045 to the power of 2 gives me 1,744.55. So if I subtract 1,500, that gives me an interest of £244.55. So in this case, yes, it affects who will get the most interest. Shiv would now get more. So that's how we'd do. Okay, so this question is standard form and also using your calculator. So it's told you to work out this calculation. So in your calculator, you can actually just type in 7.2 times 10 to the power minus 5 divided by 3 times 10 to the power minus 2. And what you would get is 0.0024 if you've entered everything in correctly. Remember to use the brackets carefully so that your calculator knows what to do in what order. So your answer would be 0.0024, but it says give your answer in standard form. So what I'm going to do is just convert it. So for a number to be in standard form, it needs to be between 1 and 9.9 times by 10 to the power of something. And this is negative standard form because it's a decimal that's making the number smaller. I'm dividing by a power of 10. So what I do is I count how many zeros there are before the number begins. So 1, 2, 3. So it'd be 2.4 times by 10 to the power of negative 3. And that's all we need to do for that question. Okay, so next I've got the laws of indices. So the law of multiplication is that I add the indices. So I know that p to the power of 5 plus x is going to be p to the power of 12, because when you're multiplying indices, you add the powers. So then to figure out what x is, I just need to think what plus 5 would give me 12, and 7 plus 5 would give me 12, so therefore x is 7. Then we've got the laws of brackets. So what happens when you're multiplying indices when they're in brackets is you add the powers. So I know that 6 to the power of 3y is going to be equal to 6 to the power of 21. Therefore, 3y equals 21 and y must equal 7. Okay, next a slightly trickier question. So I'm told that 16 to the power of a times 4 to the power of b can be written in the form 2 to the power of w. Now the key here is that they've given you a clue that it can be written in the form of 2 to the power of something. So your base number is 2. And hopefully you can recognise that 16 is a power of 2 and 4 is also a power of 2. So let's just think about our powers of 2. 2 to the power of 1 is 2, 2 squared is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16. So I could just have these here as reference, but hopefully you recognise them. So 16 to the power of a could be written as 2 to the power of 4 to the power of a. Instead of 16, I'm just replacing that with 2 to the power of 4. Similarly, 4 to the power of b, well, 4 is the same as 2 squared, so I could write that as 2 squared to the power of b. And I know that that must equal 2w. Now, what happens when I have my law of brackets is I multiply the powers. So I know that that must mean that 2 to the power of 4a times by 2 to the power of 2b must equal 2 to the power of w. And for this reason, I can then say when multiplying powers, you add them. So when multiplying indices, you add the powers. So therefore, 4a plus 2b must equal w. And that's the proof, that's the reasoning that you need to go through. So the key thing is to recognise that you can write all of these numbers as powers of 2. Okay, so in this question you are asked to find the value of the reciprocal of 0.75. Now a reciprocal is just the inverse of that number. So for instance, if you had 3, the reciprocal of 3 would be a third. So here we've got 0.75, so the reciprocal of 0.75 would be 1 divided by 0.75. Now you've got that into your calculator, so when you type it in, it's going to give you 1.3 recurring. So the key here is to recognise that a reciprocal is just the inverse. So if it's just a number, you write it as 1 over that number. If it's already a fraction, you just flip the fraction. So in this case, it's 1.33333, which is 1.3 recurring. Next, we are told that a number is rounded to 2 decimal places, and the result is 5.36. So what I want to do when I've got error intervals is just, most people are really good at this anyway, but this is just a fail-safe way to make sure that you get it. So it's rounded to 2 decimal places. So I need to think, what is the next number up and the last number down in terms of 2 decimal places? So that would be 5.37 and that would be 5.35. Now the error interval is halfway between these 2 values. So the halfway point. So the halfway point here would be 5.355. and here it would be 5.365, so halfway between those two decimals. And the error interval can neatly just be dragged down, so you'd say that 5.355 is less than or equal to n, which is less than 5.365. Normally they have this laid out for you, but the reason it's less than is because technically if it was 5.365 it would round up. But the reason we say less than is because it could be anything up to that value. So that's how we do these two. Okay, so here we've got another question. You may notice a little theme here. Spanish slightly themed paper. So 80 people were asked if they would prefer to go on holiday to Barcelona, Madrid or Valencia. Now, I'm given a lot of information here. And there are loads of ways that you can do this, but one of the best ways when I've got a lot of information, and particularly when I'm given 3 options and then 2 further options, so here I've got male and female, is to just draw myself a two-way table. It makes processing the information so much easier. So if you recognize a worded question like this that only has numbers and lots of options, I would recommend you doing a two-way table. So here we've got 3 options across. So we've got Barcelona, Madrid, or Valencia. And then we've got male, female, and then what I always want to do is have a total column. So I ran out of space here, so I'll just draw one here. So total column. Okay, so that's how you do your two-way table. You line up everything, all your options, so destination, and then whether they're male or female. And then we can just fill in the information that we've been given. So I'm just going to deal with the information that they've given. So 80 people were asked if they would prefer to go on holiday to Barcelona, Madrid or Valencia. So the total is 80 people. 35 of the people were male, so where there's males I'm going to put that in. And then 27 of the 43 people who said Barcelona, so Barcelona, 43 people said that, and 27 of those people were female. I'm then told that 9 males said Valencia and 17 people said Madrid. So that's all the information that the question has given me. And now it's up to me to do a little bit of problem solving. And this is kind of fun. It's like, you know, just finding the missing value. So over here, I can find out how many females there were because I know that they all must add up to 80. So 80 take away 35 is going to give me 45. So I can fill that in. And from then on, it's just finding the missing value and filling it in. So this is 45. What can I work out next? Well, there's a missing value over here. So I'm going to do 80, take away 43, take away 17, which is 20. Because your totals always need to add up to 80. Then for Valencia, it needs to add up to 20. So I know that there were 11 females. And then there's a nice little missing value here. So I'm going to do 45, take away 27, take away 11, which is 7. Now, the question is, I don't need to figure out these two. I can if I want to, but I don't need to, because it says one of the females is chosen at random. So I know that the probability is going to be out of 45 because there are 45 females. It's not said someone is chosen, it said one of the females. So that's why it's out of 45. And then it says, what is the probability that this female said Madrid? Well, 7 females said Madrid out of a total of 45 females. So when we're doing probability, you always have to have your denominator as the total of what the question is asking you. So it's asking you for females, so the total is out of females. Okay, so here we've got a bearings question, and I'm told that the bearing of ship A from ship B is 120 degrees, and I then need to work out the bearing of ship B from ship A. So the first thing I would recommend doing is drawing out a little diagram for yourself here. So the bearing of ship A from ship B is 120 degrees. So if you try and visualize 120 degrees, you know it's slightly more than a right angle. So ship B must be here, and that's an angle of 120 degrees. And then ship A can go here. Now with bearings, you always have a little line going up due north, and that's why bearings are so cool, because they always create parallel lines, and we can use the laws of parallel lines to help us out here. So the bearing of ship A from ship B is 120 degrees. Remember that when we're doing bearings, it says the bearing of ship A from ship B, so we always start from where it says from. So it says from ship B, that's why ship B is the one that comes first. Now I need to work out the bearing of ship B from ship A. So what do I do when I have bearings? I always start from due north. So I start from where the bearing line is, and I always have to go clockwise. So I'm going to be working out this angle here. That's the bearing. Due north, clockwise, and you have to write it as a 3 figure thing. So always do that. So what do I need to do? Well, I know that these two are due north. So therefore, this is parallel lines. And I can work out what this angle here is, because co-interior angles sum to 180. Therefore, this angle here is 60 degrees. So what I need to work out is what this angle here would be, because that is my bearing. And all I need to do is 360, take away 60, which is 300 degrees. And the reason for that is because angles on a point sum to 360. So with bearings, the key thing is draw them out, draw a little sketch for yourself, and where you're going from is where you start. Okay, so now we've got some simultaneous equations. Now, this is a calculator paper, so don't be alarmed if they're not nice numbers. And if they are not nice numbers, like if they're a really long decimal, leave it as a fraction, because then you get the exact value. So the key thing with simultaneous equations is I want to make sure that one of my variables are the same value. So neither the x's nor the y's are the same value. So what I'm going to need to do is manipulate the equations, which means I'm going to multiply them by something so that at least either my x's or my y's are the same value. Now, I could multiply the y's to get the lowest common multiple, which is 15y, or I could multiply the x's to get the lowest common multiple, which is 12y. So I'm going to opt for doing the x's. So the lowest common multiple of 6 and 4 is 12. It always just helps doing the lowest common multiple. You don't need to, but it makes your life a lot easier. So to get to 12, I'm going to multiply this whole equation by 2, and then I'm going to multiply this whole equation by 3. So 6x times by 2 is 12x. 5y times 2 is 10y, and 17 times by 2 is 34. Then 4x times 3 is 12x, 3 times 3 is 9y, and 1 times 3 is 3. So now that I've got two of my variables that are the same, so the x's are the same value in both of the equations, I need to decide whether I'm going to add or subtract. Now, you're always going to want to cancel the variable that is the same, so you need to decide whether adding the x's or subtracting the x's is going to cancel them out. Well, I know that 12 plus 12 is 24, and 12 minus 12 is 0, so I'm going to subtract. So I would always recommend putting a big either add or subtract over here to remind you. So I do 12 take away 12, which is 0, so that cancels. Then I'm going to have to do minus 10 minus positive 9. So minus 10 minus positive 9 would be minus 10 minus 9, which is minus 19. So that would be minus 19y. And 34 take away 3 is 31. So this does not look like it's going to be a nice number. So I'm going to leave it as a fraction. So what do? I'm going to divide both sides by minus 19. So I'm going to be left with minus 31 over 19. So not a nice number, but if I leave it as a fraction, I can easily manipulate it. So y is minus 31 over 19. I then have to substitute that into one of the equations to figure out what the value of x is. So I know that 4x plus minus 31 over 19 times by 3, is 1. So let's type this into our calculator. So as a fraction, you've got 31 over 19, negative 31 over 19, times by 3 is going to give you, so 4x plus minus 93 over 19 must equal 1. Now a plus and a minus next to each other are always going to become a negative, so 4x minus 93 over 19 equals 1. So 4x must be 1 plus 93 over 19. So 1 plus 93 over 19 is 112 over 19. So therefore x is going to be that divided by 4, which is 28 over 19. So not the nicest numbers to work with, but that's why if you've got complicated numbers, leave them as a fraction, because then they're accurate. Now to double check your answers, you would need to substitute x and y in, and as long as they work, then you know you've done the simultaneous equation correctly. Okay, so here we've got a cumulative frequency and a box plot. I'm told that in a dance class, 60 students tried to learn a new move. The cumulative frequency graph shows information about the times taken for the 60 students to learn the move, and that for these 60 students, the least time taken was 22 seconds, the greatest time was 98 seconds, and I need to draw a box plot. So box plots and cumulative frequencies go really, really well together, because we can read the key values from them. So with a box plot, you generally have something that looks like this. Okay, so these are the key values. You've got the lowest value, the highest value, the median, the upper quartile, and the lower quartile. So the first two values that I know that I've been given are 22 seconds and 98 seconds. So I could just draw that on my box plot. Now first I want to look at what scale it's going up in. So I know that there's 10 squares between 20 and 40, so halfway through that would be 30, and therefore 5 squares between 20 and 30 means that the scale's going up by 2. So 22 would be over here, and 98 would be over here. So that's my lowest value and my largest value. Now what I need to do is figure out what the median, the lower quartile, and the upper quartile is. So there are 60 students. So from my cumulative frequency, the way I work out the median is I halve the total value of the cumulative frequency. So the median would be 30. The lower quartile would be a quarter of the total. So a quarter of 60 is 15. And 3/4 is the upper quartile, so that's 45. So I'm going to read from 30 along my cumulative frequency, go to the graph, and then go down, and that would be 50 to 4. So I know that my median is 54 seconds. My lower quartile, I'm now going to find out. So I go to 15. I go across to the line and then down, so that would be 42. And then my upper quartile would be 45. And that takes me to 64. So let me just double check those because I don't have, yep. So now I draw my median at 54. So 54 would be here. My upper quartile would be at 64. And my lower quartile is at 42. So they make the box part. And then I just connect it with the lowest value and the highest value. Okay, so here I've got a question that tells me that I have a solid cylinder with a base radius of 3.5 and a height of 9 and a solid cube. Now the cylinder is made from copper with a density of 5.49 and the cube is made from bronze with a density of 6.3. I'm told that the mass of the cylinder is equal to the mass of the cube. So I know that I'm going to be working with density here. The formula for density, which you should know, is density is mass over volume. Because I'm working with volume, mass and density, I know that it's going to be a question linked to this. So I know I'm going to have to try and substitute values into this formula to work out what I can. Now I need to work out the value of L, which is the length of one of the sides of a cube. If I'm dealing with volume, I know that the volume of this cube is going to be L cubed, because a cube has equal sides, so this would be L as well, and this would be L as well. And to work out the volume of a cube, you do base times height times by the depth. So I know that the volume of the cube is going to be L cubed. Now the volume of this cylinder, how do you work out a volume of a prism? You work out the area of the cross section, which is the uniform part that you can push all the way through the shape without it changing, and you multiply it by the height. So I'm going to need to do the area of the circle is pi r squared. So I'm going to need to do pi times by 3.5 squared times by 9 to work out what the volume is. And if I type that into my calculator, I would get 346. So I haven't left much space here, but the volume of the cylinder is going to be 346.36, and going on and on and on. What you want to do is either write out all of the values of the decimal, or save it as an answer in your calculator. You don't want to be rounding. This is a key mistake that people make. They round to 1 or 2 decimal places and then their whole final answer is off. So make sure you only round at the very end of the question, and that's for any question. So the volume of the cylinder is this. Now I know that density is mass over volume. They've told me that the density of the cylinder is 5.49. So I know that 5.49 is the mass over volume, which is 346 point blah 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 blah. So now what I can do to work out the mass of the cylinder, I would do the density, which is 5.49, times by the volume. Just rearrange the formula. So you know that if you didn't know, then the rearranged formula would be mass is density times volume. So that would give me a total mass of 1,901.51, going on and on and on. Don't round. I'm not writing all of the numbers out just for speed. So I know that the mass of the cylinder is that much grams. Now the mass of the cylinder is equal to the mass of the cube. So I know that the mass of this cube is 1,901.51 blah, 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 grams. So what can I do now? I know what the mass is. I know what the density is. The density is 6.3. So I can use that to work out what the volume is. So once again, let's rearrange the formula. To rearrange this formula, I would just say that volume is mass over density. If you're not familiar with rearranging formula, practice that, because otherwise a lot of this stuff will be a lot more confusing than it needs to be. So volume is going to be mass divided by density. So the volume of the cube is going to be the mass, which is 1,901, which you can just leave as an answer, and I'm going to need to divide that by my density, which is 6.3. So if you don't reset your calculator, you just leave your answer, then you don't need to worry about writing all of the decimal digits out again. And then 1,901 divided by 6.3 is going to give me 301.828, going on and on and on. Now I know that the volume is L cubed. So if the volume of this is 301.828, then L cubed is 301.828. So to work out the final part, what is the length of L, I would just do the cubed root of 301. So therefore L is going to be 6.7079 going on, and it says to 1 decimal place, so 6.7, look next door, it's a 0, so that would just be 6.7. Okay, so here I've got a question about a safari park. I'm told that in the safari park there are 12 senior meerkats and 150 junior meerkats, like juvenile children. So of these junior meerkats, 70 are girls and 80 are boys, and they're going to be photographed to represent the safari park. So 1 senior meerkat, 1 girl and 1 boy are going to be chosen. And I need to work out the different number of ways there are to choose one senior meerkat, one girl meerkat, and one boy meerkat. So this is like the product rule for counting. Instead of going through each senior meerkat and allocating each boy and each girl to them, which would take a very long time, I know that I can just multiply. So how many options do I have for my senior meerkat? I've got 12. How many options do I have for my boys? Well, girls, there are 70 girls. And how many options do I have for my boys? I have 80. So all I need to do is do 12 times 70 times 80, which would give me 67,200. So quite a lot of different ways to combine them, but that makes sense because with each senior meerkat, you compare them with 70 different boys and then 80 different girls for each of those 70 combinations, and then 12 combinations. Okay, so here I'm told that Ahana wants to work out an estimate for the total number of birds in a country park. Now on Monday, she catches 150 birds in the country park, and she puts a tag on each of these birds and releases them back. So with capture recapture, with estimating a population, what we're thinking is on any given day, if I capture a certain amount of birds, they can be representative of the total population. And then on another day, if however many birds I catch, the amount that are tagged can represent the amount I caught. So this will make a little bit more sense. So on Monday, she catches 150 birds out of X, which is like the total number of birds that there are in the park. On Tuesday, she catches 250 birds in total. So 250 is her total. And out of those 250 birds, 30 of them are tagged. So we're assuming, this is why it's an estimate for the total number of birds, we're assuming that 30 over 250 is in the same proportion as 150 over X, which is the total population. So this is just a simple rearranging formula. I would say that 150 is equal to 30 over 250 times by X, and therefore X must be equal to 150 divided by 30 over 250. So if I type that into my calculator, I would get 1,250, and that would be representative of the total population. If you think about it, 150 over 1,250 is an equivalent fraction to 30 over 250. There are loads of different ways you can do it, but because it's a calculator paper, the quickest way is just to rearrange the formula to figure out what X is. And remember that X is the total population. Okay, so here's a nice easy equation of a circle question. Hopefully you know what the equation of a circle is. If you don't, it's really simple. So the equation of any given circle for GCSE is x squared plus y squared equals the radius squared. Okay, so that for any circle you're given, this is the equation. So we need to work out what the radius of the circle is. We know that 56 must represent r squared, so we know r squared is 56.25. Therefore r is going to be the square root of 56.25, and therefore the square root of 56.25 is 7.5. So the radius is 7.5. Okay, so here's a quadratic sequence. Now there's two main ways that you can do quadratic sequences, either by equating the coefficients, so where you use the formula method, or by the more kind of less formulaic way. So I'm going to do the second option. If you know it the other way, then just disregard everything I'm saying. As long as you get the right answer, that's fine. So when I look at a quadratic sequence, the first thing I want to do, just like with a linear sequence, is just notice what the difference is. So from 5 to 12, what's happening? I'm adding 7. From 12 to 23, I add 11. From 23 to 38, I add 15. And then from 38 to 57, I add 18, 19. So what you notice is the first difference is not the same. That's great. That means it's not a linear sequence, and you're even if they don't tell you it's a quadratic sequence, you should think to yourself, okay, it's going to be a quadratic sequence. So I'm going to look for the second difference. So second difference, what am I adding? I add 4. Over here, I add 4 again. Here, I add 4 again. So now I've got a constant difference. So my second difference is 4. And what we do is we halve the second difference. So we halve the second difference, and that tells us what the coefficient of n squared would be. So I know that the first part of my quadratic sequence is going to be 2n squared, which means it's going up in the 2n squared times tables. Now what's really handy is if you know your square numbers, so 1, 4, 9, 16, you just write them out, because that will help you with the next part. So what is the 2n squared times tables? Well, I know that the square numbers are 1, 4, 9, 16, so 2 lots of the square numbers, 2 times by n squared is going to be 2, 8, 18, 32. So I just write out, because I know it's going up in the 2n squared times tables, I write that out. I could even write that out over here. So 2, 8, 18, 32. Then what I do is I try and find out what the difference is. So just like with linear sequences, now I'm going to write it in the table too, just so that you can see. So the original sequence is 5, 12, 23, 38. And what I'm doing is I'm trying to see what the difference is. So how do I get from 2 to 5? I add 3. How do I get from 8 to 12? I add 4. How do I get from 18 to 25? I add 5. And 32 to 38, I add 6. So the sequence it's then going up in is 3, 4, 5, 6. So step 1, halve the coefficient. That tells you what n squared it's going up in. Compare that to your original sequence to figure out what the linear sequence is. And then we want to work out the nth term of this. So it's going up each time in ones. So I know it's going to be n. And then if it were the 1 times tables, it would be 1, 2, 3, 4. So it's n plus 2 each time. So therefore the full quadratic sequence, the nth term would be 2n squared, which I already worked out, plus n plus 2. So lots of different ways to do it. This is just one of the ways. The key is first halve the second difference. That's whatever n squared it's going up in. Then compare that to your original sequence. This would then create a linear sequence for you. And from this linear sequence, work out the nth term, and that's the second part. So first part, second part, and then bunch them together. Okay, so here I've got some algebraic fractions, and I need to show that these 3 fractions simplify to n over y. So when I'm adding or subtracting fractions, whether it's algebraic or just normal numerical fractions, they need to have the same denominator. So that's the first thing you're going to do when you're looking at these. You're going to think, what's the lowest common multiple of all of these denominators? And in this case, I can see that all of these denominators would nicely multiply into 8xy, so I don't need to do too much to rearrange them. So this one is obviously going to remain the same, 10x minus 2y. Now 2x times by 4y is going to give me 8xy. So this whole fraction is being multiplied by 4y. So this numerator is going to be 1 times 4y, which is 4y. And then here 4xy times by 2 is going to give me 8xy. So I'll multiply the whole fraction by 2. So that would be 2 lots of y minus 3x. I'm just multiplying the numerator. Now I can bring all of these terms under the same denominator. So I've got 10x minus 2y plus 4y. And then this is the bit that some people get caught out on. I've got minus 2 times by y, so that would be minus 2y. But then minus 2 times by minus 3x would be positive 6x. So now, and the reason I've put them all together is because once the fractions have the same denominator, you just add the numerators together. So now I'm going to collect all the like terms. I've got 10x plus 6x, which would leave me with 16x, and then minus 2y. Minus 2y is minus 4y, and minus 4 plus 4 is 0, so all the y terms would cancel, and you'd be left with 18x over 8xy, which let's simplify that. So I can divide by x, and that would leave me with 16 over 8y. And then what I can do is I can divide by 8. So 16 divided by 8 is 2. So I'd be left with 2 over y. So that's how we'd show each step of our working in order to lead to that conclusion. And we could say that n is 2, but what you want to do is show your method and then how it cancels. Okay, so in this question we've got 3D trigonometry. Now with 3D trigonometry, the key is to try and visualize it, and then any kind of right angle triangle that you recognize within the 3D shape, draw them out as 2D so that you can work on it separately. So let's have a look. We're told that A, B, C, D, E, F, G, H is a cuboid. We know that AB is 6.8 centimeters, so this line here, which means that DC will also be 6.8, EH and FG. We know that CH is 7.5 centimeters, and the angle BCA is 52. So this is where we want to think about where would angle BCA be. So B, C and A would be connected like that. So that would be a little right angle triangle over here on the base of the cuboid. So we could draw that right angle triangle here. So I know it's a right angle because it's a cuboid, so this angle here would be a right angle. It's just kind of difficult to visualize, but if you visualize the base of the cuboid, it's a flat 2D rectangle, and the length that I know is AB, which is 6.8, and I know this angle here must be 52 degrees. So what can I do? Well, I'm aiming for, I want to find the size of the angle between AH and the plane ABCD. So if we think about AH is up here, and the plane ABCD is this thing here. So therefore, the angle that I would want is this angle here, so that it can form a right angle triangle with HC. So it's like seeing a triangle within the 3D shape. So if I know that, then I know that I'm going to need to work out what AC is, because that's going to be useful for my triangle. So I've got this triangle to begin with, and if I work out what the hypotenuse is, that is going to be what AC is. So let's do it step by step. So I know I'm going to use trigonometry. It's always helpful to write out SOHCAHTOA, even if you know it off by heart, just because there's so much going on, just to reduce your working memory. So this is the angle I've been given. This is going to be the hypotenuse, and this is therefore going to be the opposite. And I want to find the hypotenuse, and I've been given the opposite, so I know I'm going to use SOH, opposite and hypotenuse. So I know that sine 52 is going to be equal to opposite 6.8 over the hypotenuse, which is x. And now all I need to do is just do a simple rearranging. Remember, when x is your denominator, all you need to do to switch x to be the subject is whatever's on this side, switch it with x. So 6.8 divided by sine 52 is going to give you the value of x, which is the hypotenuse. So 6.8 divided by sine 52 is 8.629323862. Remember, don't do any rounding until the very end. So I know that AC is 8.62932. So then I can say goodbye to that triangle. It served me well. And now I want to move on to my next 3D triangle. So remember, AH is this line here, and the plane is the 2D face of the base of the cuboid. So what angle would that be? It would be over here. Okay, and then the right angle triangle would be here. Now they've told me that the CH is 7.5, so I know this value. If I draw out the triangle here, I know this is 7.5. This will be my right angle. This is the angle I'm looking to figure out. And I also know that AC is 8.62, which I've just worked out. So once again, I'm going to just write out SOHCAHTOA, just because it's good practice. Label my triangle. So this is the adjacent because it's next to the angle, and this would be the opposite. So I'm using the adjacent and the opposite, which is tan. So I know that tan theta, and theta is just a symbol for an angle, tan theta is going to be opposite, which is 7.5, over adjacent. And I would even recommend you writing tan theta equals opposite over adjacent, because the amount of mistakes that are made just because people accidentally type in the opposite and the adjacent the wrong way around, or you know, that's just advice. You do what you want. Okay, so now I want to work out what theta is, so I'm going to have to do the inverse of tan 7.5 over 8.62. So I have my answer saved into my calculator. Instead of writing out all of the decimals, what I can do is just press shift tan and then in brackets do the fraction button, so it looks like that, and then write 7.5, and then over here you have an answer button, and that saves whatever was the last thing that was in your calculator. So instead of typing it out, you can do that and then press equals. So that would give you an angle of 40.99486.841. It says give it correct to one decimal place, so the angle is going to be 41.0, because it's one decimal place. Even though 40.999 rounds to 41, it wants it to one decimal place. So even though 41 is the same as 41.0, you have to write the 0.0 because that's to one decimal place to show that you've rounded it. And that's that. So the trick is just visualizing where the right angle triangles could be and then working from there. Okay, so in this question I am shown a hemisphere, which is half of a sphere, and I'm told that its diameter is 9.2 centimeters, and I need to work out what the volume of the hemisphere is. They have kindly given me the formula for the volume of a sphere. So all I need to do is half it. Now there's a few ways you can do it. You could work out the volume and then half it, or you know that dividing something by 2 is the same as multiplying it by a half, so you could incorporate that into your thing, whatever you want to do. So to work out the volume of the hemisphere, let's do it bit by bit actually. Let's do it to work out the volume of the sphere. If this was a full sphere, I would have to do 4/3 times by pi times by the radius cubed, and this also catches people out. You've been given the diameter, so to work out the radius we're going to halve the diameter, and that would be 4.6 centimeters. So I'm going to do 4/3 times pi times 4.6 cubed. That would give me the volume of the sphere. And then you just divide it by 2 to work out the volume of the hemisphere. So 4/3 times by pi times by 4.6 cubed gives you 407.72, and we're just going to then divide that by 2, which is 203.86, 00417. So that's the volume of hemisphere, and they've said give it to 3 significant figures. So 203, I'd circle the 3, look next door, it's going to round up, so that my final answer would be 2. Okay, so yes, you might have noticed that there's a little Spanish theme to this. It's because I went to visit my friend in Barcelona and was writing this in the airport as my plane was delayed. So in Barcelona over the summer, if it is sunny on one day, the probability that it will be sunny the next day is 0.9, and if it is not sunny on one day, the probability that it will be sunny the next day is 0.7. Now Miss Costa is going to visit her friend in Barcelona, and her friend says that there is a 99% chance that it will be sunny on Friday. So a lot of words here for a question. We want to extract the key information. Now I need to work out an estimate for the probability that it will be sunny in Barcelona on Sunday. So you've got Friday, Saturday and Sunday that you need to take into account. So I'm told that there's a 99% chance that it will be sunny on Friday. So on Friday, what are my options? It'll be sunny, not sunny. And the chance of it being sunny is 0.99. So therefore the chance of it not being sunny is 0.01. So that's Friday. Then what I want to do is think about what could happen on the Saturday. So there's 2 options, because it could have been sunny or it could have been not sunny. So let's do the probability tree that way. So the probability on Saturday of it being sunny, because if it's sunny on one day, the probability that it'll be sunny the next day is 0.9. So probability that it's sunny on Saturday would be 0.9, and not sunny would be 0.1, because your branches always need to add up to 1. Then if it wasn't sunny on the Friday, so if it's not sunny, the probability that it will be sunny the next day is 0.7. So the probability it's sunny would be 0.7, and therefore not sunny would be 0.3. I didn't leave much space for myself, but hey, what can we do? And then we've got the final part. So we've got, what are our options for Sunday? How many ways could it be sunny? There's 4 ways. So if on Saturday, if it was sunny, it would be 0.9, and not sunny would be 0.1 again. If it wasn't sunny, then the probability of it being sunny would be 0.7, and not sunny 0.3, and then sunny again would be 0.9, not sunny would be 0.1. If it wasn't sunny, it would be 0.7 and 0.3. So now we've got our probability tree. We didn't necessarily have to do it in a probability tree, but sometimes it just helps. You could have just listed what your options would have been. Now we want to think about what routes we can take. So the ultimate aim is we want to work out an estimate for the probability that it will be sunny in Barcelona on Sunday. So this is Saturday, this is Sunday. So you've got option 1. We could go sunny, 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 which would be 0.99 times by 0.9 times by 0.9. We don't want this route, so we don't need that. Anything else? No, we've extinguished that branch. We look at the next branch. It could be sunny, not sunny, and sunny. So option 2 would be sunny, not sunny, and sunny. Maybe I don't need to write that because that's confusing. But 0.99 times by 0.1 times by 0.7. So we don't need that option either. So then we go down here. Option 3, it could have been not sunny on Friday, so 0.01, but then it could be sunny and sunny, so times 0.7 times 0.9. Another option could have been not sunny, so 0.01 times by 0.3 times by 0.7. So ideally I would have had a little highlighter to show those routes, but those are the routes that I take. So those are my options. I work out what the probability of each of these is. So I haven't got much space. I'm just going to write them down here. So you've got 0.99 times by 0.9 times 0.9 would be, oh gosh, and this isn't, it would be 0.8019. 0.99 times 0.1 times 0.7, so that's option 2, is going to be 0.0693. Then we've got 0.01 times 0.3 times 0.7. I did the 4th one by accident, which would be 0.0021. And then we've got 0.01 times by 0.7 times by 0.9 would be 0.0063. So they're your possible options. So when we've got a probability tree, we multiply along the branches and then we add the final probabilities together. So we add this plus 0.021 plus 0.0693 plus 0.8019, which gives you a final answer of 0.8985. So it just says work out an estimate for the probability. You could turn it into a percentage if you want, just to make it more percentagey, because that's what's been given in the question. So that would be 89.85% chance that it would be sunny on the Sunday. Okay, so here I've got a bounds question. Now these often come at the very end, and the key thing you need to remember is do not So what a lot of people do is they work out the calculation and then they figure out the upper and the lower bound at the end. That is not what you want to do. Every piece of information that you've been given, you want to work out the upper and the lower bound of that before you enter it into the calculation. In this question, we don't actually have that much to deal with, but so we only have one value, so it's not that big a deal, but you still need to apply that method. So I'm told that A is a quarter of B cubed, and I'm told that B is 12.6 correct to 3 significant figures. So by considering bounds, work out the value of A to a suitable degree of accuracy. So when you get a question like this where it says to a suitable degree of accuracy, what that means is you're going to have to work out what all of the outcomes would be and then see what they would easily round to. So that will make more sense when we do it. So first of all, I'm going to work out what the upper and the lower bounds of B are. So it's 3 significant figures, and in this case the third figure is the first decimal place, which means it's to 1 decimal place. So 3 significant figures, it could be 12.5 or 12.7 if it rounded up or down. So to work out the bounds, the lower bound would be halfway between this. So that would be 12.55 is the lowest value it could possibly be. And the upper bound would be 12.65. Now, technically it would be 12.649 recurring, but with bounds questions, we just round it just to make our lives easier. So I know that the lower bound is 12.55 and the upper bound is 12.65. So then what I'm going to do is enter that into my calculation. So A is a quarter times by 12.55 to the power of 3, or A could be a quarter times by 12.65 to the power of 3. So I'm going to figure out what those two are. So 0.25 times by 12.55 to the power of 3 is 494.1640938. And then the same thing, but times 12.65 to the power of 3 gives me 506.0711563. So I've worked out what the possible upper limit and the lower limit of this would be, and I need to round it to a suitable degree of accuracy. So if I rounded it to, let's say, 1 decimal place, this would be 494.2, this would be 506.1. They're not the same, are they? If I rounded it to the nearest whole number, it would be 494, and this would be 506. Again, they're not the same. If I rounded it to the nearest 10, or to 2 significant figures, that would be 490, and this would be 510. Again, that creates an even larger gap. If I, however, rounded to 1 significant figure, this would round to 500, because I'm looking at the 4, and this would also round to 500. So by considering bounds, I would say that A is 500 to 1 significant figure as both values round to this. Okay, so the reason would be if I rounded to anything else, the values would be not the same. Okay, so here we've got a complicated looking question, but if we break it down, as with any maths problem, we just want to apply any kind of maths tools that we have, throw them at it, and then see where that takes us. So I'm told that OAC is a sector of a circle. Centre O, radius 12 centimetres. BA is a tangent and BC is a tangent. So already I should be thinking, okay, well, I know that two tangents from the same point are the same length. I also know that a tangent and a radius meets at 90 degrees. So I know that BA must be the same size as BC because 2 tangents from the same point are equal in length. That's a circle theorem. And then I also know that a radius and tangent will meet at 90 degrees. So I can already start filling in some information there, even if it's not 100% necessary. I also know the radius is going to be equal. That's the whole point of being a radius. It's equal to every other radius because it's from the center to the outside. So I've got 2 equal sides here and 2 equal sides here. So I know that I'm dealing with a kite. Now I need to work out the area of the shaded region, and I need to give my answer correct to 3 significant figures. So there's a few ways we can do this. This is a kite. So what I could do is, first of all, I know that I'm going to, when I work out a shaded region, I do the area of the whole thing, take away the non-shaded bit. So first of all, it might be a good idea to work out the area of the arc sector. Sorry, why did I call it an arc sector? Just the area of the sector. And a sector is just a part of the circle that's been split up. So to work out the area of a sector, all we do is we do whatever the angle is over 360 times by pi r squared. So this is a fraction of the circle. If I simplified that, it would be 14 over 36, which would be 7 over 18. So it's 7/18 of the circle. That's why I do 7/18 times by the area of the whole circle, but I don't need to simplify it because I've got a calculator. So times by pi times by radius squared, that's going to give me the area of the sector. So let's just type that into my calculator and we'll save that information for later. So 140 over 360 times by pi times by 144 is 56 pi. It's always better to leave your things in terms of pi instead of writing all of the decimals out. So that's the first bit, the area of the sector. Now I need to figure out how to work out the area of the whole shape. So what I could do is split this into 2 right-angled triangles. I'm splitting the shape exactly in half, so this is going to create this 2 lots of this type of triangle. So I've got, this is my tangent, this would be A, this would be B, and this would be O, and half of this is going to be 70. I know that AO is the radius, which is 12 centimeters. So what I could do is figure out what AB is, because to work out the area of a triangle, we just do base times height divided by 2. So using trigonometry, I've got SOHCAHTOA, I've got the adjacent, and I want to work out the opposite. So adjacent and opposite is tan. So I know that tan 70 is going to be adjacent, no, it's going to be opposite, which is AB, over adjacent, which is 12. So therefore AB is going to be 12 tan 70. So AB is 12 tan 70 is 32.969. So that's not a very nice number. So I'm just going to save this somewhere over here. So AB is 32.9697293. So now I know the length of that. I can use that to work out what the area of the triangles would be. So area of triangle is going to be base, which is 12, times by height, which is 32.9, divided by 2. So 12 times by answer divided by 2 is 197.818372. So that's the area of one triangle, so 197.81, and I'm going to times it by 2 to work out the area of the whole shape. So times by 2 is 395. So area of whole shape is 395.637. And to work out the area of the shaded region, I'm just going to do the whole area, 395.63, take away the area of the sector, which I worked out earlier, which is 56 pi. So all of this shape is 395.63, and I'm subtracting 56 pi, which is that. So answer, take away 56 pi, gives me 219.707, blah, blah, blah. It's a 3 significant figure, so I'm going to say 220 centimeters squared. And that's your final answer. Okay, so here I've got a vectors question. So with vectors, the first thing you want to do is make sure that all the information that you have is written on the diagram. So I'm told that OA is 2A, so this vector here is going to be 2A. And then told that AB is a half B. And I'm told that OC is 12AB. So I know that AB is a half B, so a half times by 12 is going to be 12 over 2, which is 6. So therefore, it's going to be 6B. I'm told then that D is the point on OB such that OD to DB is 1 to 2, and E is the point on BC such that BE to EC is 1 to 3. I need to work out the vector DE in terms of A and B. So this is what I want to work out. I want to work out how to get from D to E, but with vectors you can only go along the vectors that you know. So if you think about it as like routes that have already been traveled, you can only go down the known roads. You can't just fly into space without following a route that's been given to you. So there's a few vectors that I could work out. So DB is along the vector OB, and that is a vector that I can work out. So the vector OB, I want to work out what that is, but I can't go along this unknown path because this has no vector information. So I can't go along there. How else could I get from O to B using vectors that have already been given to me? So here I can go along OA. So a route to get from O to B would be going along OA and then AB. So that's just my route that I've written down to help me. Now I know that OA is 2A and I know that AB is a half B. So therefore OB, the vector OB is 2A plus a half B. Now if I want to get from D to E as my end point, then I'm likely going to want to use DB and then BE. So the next sensible thing would be to figure out what the vector DB would be. So I know that DB is 2/3 of OB. So the trick here is converting the fraction parts into vectors. OD is 1/3 of OB because the parts are 1 to 2. So in total there's 1 part to 2 parts. So as a fraction it would be 1/3. So if I want to work out what DB is, that would be 2/3 of whatever OB is. Okay, so I know what OB is, therefore it's going to be 2/3 of 2A plus a half B. So 2/3 times by 2 is 4/3 A, and 2/3 times by a half is going to be 2/6, or I could simplify that to 1/3. It's always best to simplify. So I know that DB is 4/3 A plus 1/3 B. So I'm just going to save that somewhere over here. Where can I save that? DB is 4/3 A plus 1/3 B. You're going to have lots more paper than me, so you're not going to need to worry about all of this space. Okay, the next thing that I'm going to want, so I've figured out what this is. I know it's 4/3 A plus 1/3 B. Now, what I'm going to want to figure out is what BE is. So in order to do that, I'm going to need to work out what BC is and work from there. So BC, how can I get from B to C using the vectors that I've already figured out? I mean, I could actually use BO that I've already worked out, but it's going to be a lot easier if I just go along the routes that they've given me. So when you're changing direction, so AB is a half B, but I'm now starting from B going to A, so it's going to be negative half B. So when you're changing the direction, it becomes a negative. So BC is going to be BA plus AO, which is this way, plus OC. So what are those vectors? Well, BA is going to be minus a half B, AO is going to be minus 2A because I'm reversing the direction, and OC is plus 6B. So now I just collect those together. So half B minus, so 6B minus a half B is 5.5 B minus 2A. So that is the vector BC, and I know that BE is a quarter of BC. So if you're struggling with this part, this is just the ratio part, it's just turning ratios to fractions, so practice that. It's because this is 1/4, this would be 3/4. So BC is 5.5 B minus 2A, and BE is going to be a quarter of that. So let's actually turn that into a fraction. So 5 times 2 is 10 plus 1 is 11. So that would be 11 over 2b minus 2a. Let's multiply out the brackets. That would be 11/8 b minus 2 over 4 would be a half a. So that's what BE is. And now that I've worked that out, I can bring both parts of my vector together. So I know that DB is this, BE is that. So to get from D to E, I can go along DB. So let's just write that out. So DE is going to be DB plus BE. And that is 4/3 A plus 1/3 B plus 11/8 B minus a half A. So let's deal with our fractions. We've got 4/3 A minus a half A. So you've got a calculator actually. I don't know why I'm doing all of this in my head. So 4/3 take away a half is 5/6. So when I collect the A terms, that would be 5/6 A, and then a third plus 11 over 8 is 41 over 24 B. So that's your vector in its simplest form. Okay, so in this question I'm dealing with graph transformations. So here is the graph y equals f of x. This is the function. This is what the graph of the function looks like. For the first part of the question, I'm asked to draw the graph of what? Oh, that's the second part, sorry. For the first part of the question, I'm asked to draw the graph of y equals f of x minus 5. So what is happening is happening outside of the function. So this is where, so the function is a bit that's inside the brackets. So when something is happening to it outside of the function, it's dealing with whether we're going to be going up or down, and it affects the y coordinates, and it does what it says on the tin. So it says f of x minus 5, so I'm literally moving every y coordinate down by 5. So all I'm going to do for this is every y coordinate moves down by 5. So let's take a look. The x values stay the same. I'm just going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and here. So this is the first part of the question. Okay, so when something's happening outside of the function, you do what it tells you to, but it's dealing with the y-axis, so it's whether it moves up or down. The next part, it says, on the grid below, draw the graph of y equals f of minus x. Now, this is a little bit trickier. So when it's inside of the function, it's dealing with the x-axis. So because we're dealing with the x coordinates, every x coordinate is now going to be the inverse of what it was. So the y values stay the same, but we're dealing with the x coordinates and we do the inverse. So the 2 is now going to be minus 2. So we've got 1, 4 over here, and that's now going to be minus 1, 4. We've got minus 2, 4. That's now going to become 2, 4. I made that confusing by drawing that. Oh, damn. Okay. And then the last coordinate is minus 3, 4. That's now going to become positive 3. Positive 3, 2. So the x coordinates get flipped. And essentially what that means is it's a reflection in the y-axis. So a quicker way to remember it could be reflection in the y-axis. But the reason for that is because every x coordinate becomes a negative version of itself. So this is what our graph for here should look like. And then the last part of the question, it says, on the grid below, draw the graph of y equals f of x plus 2. Once again, it's inside the brackets. So when it's inside the brackets, it's inside the function, we're dealing with the opposite of what it tells us to, and we're dealing with whether it's going to move left or right. So it tells us x plus 2, so I know I'm going to have to do the opposite. I'm going to have to go minus 2 along the x-axis. So it's the x coordinates that are affected, and each of my x coordinates are going to shift along by negative 2, because it says positive 2 in the brackets. I do the inverse. So literally look at your x coordinates and shift them all along by 2. So that's the first one, that's the second one, that's the third one, and then 1, 2, and then that's the fourth one. So that is what your graph here should look like. So if it's inside the brackets, we do the inverse along the x-axis, and over here, if it's outside the brackets, we do what it says and it deals with the y-axis. Yeah. Okay, so here's our final question, and it's a functions question. So I'm told that the functions f and g are such that f of x is 4x plus 2 and g of x is ax plus b, where a and b are constants. So g of 3 is 13 and the inverse of f is 14, and that is equal to g of 1. So I've been given a few things, and I'm going to have to deal with something here because this is expressed in algebraic terms. So what can I do first? Well, I know that g of 3 is 13, so let's use that. So g of 3 is 13, so when x is 3, the output is 13. So I know that 3a plus b must equal 13. All I've done is I've put 3 wherever there's an x, so a, like 3a. So I know that 3a plus b is 13. I then also know that the inverse of f is something that I'm going to need to do. So let's first of all work that out. So f of x is 4x plus 2. So y equals 4x plus 2. I'm going to switch it to work out what the inverse is. So x is 4y plus 2. Rearrange it. So x minus 2 is 4y. X minus 2 divided by 4 is y. So the inverse of that function is x minus 2 over 4. So when that is 14, that's equal to g of 1. So let's substitute 14 into it. So 14 minus 2 over 4 is 12 over 4, which is 3. So I know that 3 is equal to g of 1. So g of 1 would be a plus b, because it's just one lot of x. So the difficulty here is that we're dealing with algebra, and that's going to throw quite a lot of people off. But if you just do what you've been taught with functions, which is to just substitute things in and see where you can go from there. So now we've got essentially simultaneous equations. So I know that a plus b is equal to 3, and I know that 3a plus b is equal to 13. And this is a nice simultaneous equation, as I've got b values that are the same, so I can just subtract. So 3a take away a is 2a, b take away b cancels, which is why I've done this. 13 take away 3 is 10, so therefore a must equal 5. Now if a is 5, 5 plus b equals 3, so b must be 3 take away 5, which is minus 2. So there we've got our values for our functions. So that's everything for now. Just some of the topics that could come up. If there's any last minute topics that you want in a little bit more depth, then drop a comment below and I'll see what I can do. Thank you for watching.